It's a demo for the application ATM Recommender, which we have built for the Baroda Finathon challenge. This is an implemented prototype landscape which we have built. It has the mobile application, that is the ATM Recommender mobile application, which is built, which is executed on an emulator, that is Knox Android emulator for Windows. And we have brought in Node.js to call the services in async mode. It is built in microservices architecture pattern, and if you look at the solution, it gets the ATM up down, no cache, the predicted wait times, the distance, duration, and then get the recommendation in real time. For the different inputs, we have a different service which collects inputs, and then the prediction recommendation engines are built. The ATMs from bank is a service which is taking the user location and going to the bank and getting the set of ATMs with the radius. And with that input, it gets passed into 4 different services parallelly to get the distance and duration with the traffic from Google, and the cache, no cache, up down is a set of simulator which gives us the data with a randomness. Actually, ideally, it has to come from Bank of Baroda. And we have marked the sequence of the services with the blues 1, 2, 3, 4, 5, and the green icons are the inputs and outputs for each and every service. So if you look at the wait predict time is a wrapper service which calls the arrival rate prediction and the queuing model wait time prediction. This is the first service calls an OR model, which is a linear regression which predicts the arrival rate on an ATM. And with that as an input, with the service rate, with the queues, and it builds a model to predict the wait times, that is on the queuing model theory and implementation. And all these inputs, all these parameters for the set of ATMs, the wait time, up down, cache, no cache, and the distance and duration is fed into a decision tree implementation R, which spits out the recommended ATMs, and that comes back to the wrapper service node, and which goes back to the mobile application. So we'll see the demo. We'll see how the individual services are working and how that results is really rolled up to the wrapper service and to the mobile application. So we have Node.js up and running. We have Node.js up and running, and we have the Knox player up and running. We have the set of REST APIs URLs with the input to feed in, and we have the Postman with us to show you how each and every service is responding. So let's start with it. The first is the bank API. So I think we do have created the various tabs to request each and every service. So there's a bank API, that is, it takes the user location and radius to pass, and the bank is going to return the set of ATMs. Yes. So let me go and put into JSON. So we have the ATMs that we have to basically, as per with the mock data, with the data from the bank API, we get only 2. So with the accuracy of the models, we have mocked up some more ATMs, and we do have 10 ATMs coming out. We do have 10 ATMs returned from this service. We'll go to the next service, that is Google API. So for this set of ATMs, with the user location, what is the distance and what is the duration with the traffic? So we get the addresses and we get the distance, 36 kilometers, and we get the value of this many minutes, it means seconds it's going to take. And we go to the next service, that is cache no cache. It's just a simulator. And if you look at the input, these are all the ATM codes which is going to pass, and we'll see how many ones and zeros that response that says like that is up and down. So the ones are up and 0 is down. Go to the fourth service, that is ATM up and down. you see the parameters, it's the ATM IDs. So again, with the randomness, it sends the zeros and ones, whether it is with cache or without cache. So this is the wait time prediction service, which returns the wait time for the ATM, considering the day and the hour. It is a wrapper, so it is going to call the two other services. One is arrival rate prediction and the queuing model implementation. The two queuing model implementation to predict the wait time. So the input is going to be like the ATM and whether it's what day and what hour, and let's see the output. So this comes back with the predicted time as well, 1.7 minutes predicted wait time. So this is a recommender, which is nothing but the decision tree implementation. This is a wrapper, a Java wrapper on the R implementation. So for this, set of inputs is fed in. That is for every ATM, what are the different parameters of cache, up, the wait times, and the distance and duration. So with this, yes, I think it's I think 10 ATMs we are passing. We will see a set of recommended ATMs from the decision tree. Yes. So we'll see the next service, that is the ATM recommender service, which is deployed in Node.js, which is passing the user location and getting the list of things. So this is yeah, this is a wrapper on. This means the decision tree output has to come to this wrapper. So basically, this is the connect of all the other 8 services, and with the user location and what is the recommended ATMs which is coming out from the decision tree by passing through all the n number of other services as well. So we get 3 ATMs, 2 and we get 2 ATMs, and so this is, and we will see it. We'll see the same. We'll call the same in Knox simulator and look at it and look at the results. So the mconnect plus we have this app. So the longitude and latitude of the user location is Gateway of India, and we have the ATM recommender as the mobile application, and it goes and calls the Node.js. It is again calling all the Tomcat services, and it's our model to come back the results of what is the recommended ATMs. That's it. So this is the end of the demo. Thank you.